Okay, so this is going to be a continuation of the previous video, which dealt with coming up with reasons for Chapter 2 proofs or Unit 2 proofs. And then we'll switch back and forth between the reasons and the 2E handout where we can use some of that stuff. So let me go back to the reasons. Now, in the last video, we did the first 5. So these definitions and then a couple of theorems here. And then there's this thing called the segment addition postulate, and for some reason it printed out here, and on my copy it didn't. So actually down here, put 6 and say segment addition postulate. Segment addition postulate. Okay, so in a proof, the way that the segment addition postulate can show up is it doesn't actually matter what stuff you have before you use it, because as long as B is in between A and C, you can always say AB plus BC equals AC. And this we learned in the last unit, and that's called the segment, that's using the segment addition postulate. So that's how it shows up in a proof, right? And in fact, I think we did a proof that used that somewhere. Let's see, did we? Let me check right here. Yeah, right here. We used the segment addition postulate in this proof right there, right, in the 2C handout that we did at some point. And it didn't actually matter what came before it. It turns out that we could have listed that first if we really wanted to. Okay, let's go back to the reasons. Okay, then we've got the angle addition postulate, which is just like the segment addition postulate, except the angle version. So in that one, just like the segment addition postulate says, take 2 segments that are right next to each other, add them together to get the whole segment. The angle addition postulate says take 2 angles that are right next to each other and add them together to get the big angle. So that's going to be, it doesn't really matter what comes before it because it doesn't have to build off something beforehand. But it would show up as something like measurement of angle ABD plus the measurement of angle DBC equals not 180, the measurement of the big angle, measurement of angle ABC. And the reason is, well, we're adding 2 angles next to each other to get the big angle. Angle addition postulate. And remember, there's a special case. If we add this angle to that angle, we get the big one. But in this case, you can either call the big one EFG, or you can call it just 180 degrees. So in this one, again, it doesn't really matter what came beforehand in the proof. But right here, we can say, okay, measurement of angle EFH plus the measurement of angle HFG equals, and then instead of saying EFG, I'm just going to say 180 because we know that's exactly what it is. And that's the special case of the angle addition postulate. Okay, so let's look at 8, definition of complementary angles. All right. So complementary angles, the way this occurs in a proof is, well, let's say you're given info or at some point you figured out that angle 1 and angle 2 are complementary angles. For whatever reason. Usually that's kind of a given one. Okay, well, if I tell you 1 and 2 are complementary, then you can tell me that measurement of 1 plus measurement of 2 should end up being 90 degrees. And the reason is, well, they were complementary. That's what complementary angles are. So this is the definition of complementary angles. Okay, and this one also works in reverse. If you kind of pretend that we didn't know this stuff up here, right? Let's just say you knew for some reason in your proof that 1 and 2 put together already equaled 90 degrees, right? For whatever reason. Well, if I tell you 1 and 2 add up to 90, then you can tell me that angle 1 and angle 2 are complementary angles. Because that's what they are. That's how complementary angles work. Definition of complementary angles. And then in 9, it works the same way, but we're talking about supplementary angles. So if I say, okay, let's start out with 1 and 2 are supplementary angles for whatever reason. well, then you know that they have to add up and end up being 180 degrees. So 1 and 2 added together, the measurements are going to be 180. And that's because that's what supplementary angles are. Definition of supplementary angles. And then over here, in the second version of it, you could have started with 1 and 2 already equal 180 for whatever reason. Well, if that's the case, then that means that 1 and 2 must be supplementary angles. Because, well, if they add up to 180, the definition says they ought to be supplementary angles. Definition of supplementary angles. Okay, so I'm going to stop there with the reasons, and instead, let's jump over to 2e. Okay? So in 2e, we're trying to fill in this proof, and it involves some complementary angles. So the givens are 1 and 3 are complementary, 2 and 4 are complementary, 3 is congruent to 4, which is the same thing as this, measurement of 3 equals measurement of 4. 1 is the same, and we're trying to prove 1 and 2 are the same, which is the same thing as saying measurement of 1 equals measurement of 2. So let's take a look at the proof and fill in the blanks where we can. So in this one it says 1 and 3 are complementary, right? Well, that's given, and same as with 2 and 4, it's given, right? So I'm going to cross off these guys because we've used them already. Notice we haven't used this one yet. So at some point, well, we will. All right. So if they're complementary, then the very next step you can say is that they have to add up to be 90, right? So right here it says 1 and 3 are complementary. That turns into this first step right there. 1 and 3 add up to 90. And if you go back and you look at your reasons right here, notice I started with, here's a pair of complementary angles for whatever reason. In this case, it was given. So they add up to 90, right? Because of the definition of complementary angles. So this one right over here is saying the same idea. 1 and 3 are complementary. 1 and 3 add up to 90. Definition of complementary angles. And notice it's the same deal with the 2 and the 4. Those end up being the same idea right there. So since they both say the same exact thing, you can kind of cram them into one box. You are allowed to do them separately if you wanted to, so then that would be 2 separate steps with the same reason. Okay, so let me do this. Notice right here, 1 and 3 add up to 90. And right here, 2 and 4 add up to 90. Well, they both equal 90, right? So actually, let me erase a little bit of this. 2 and 4. 1 and 3. So since they both equal 90, well, you can replace this 90 right there with the green box here. So you can just plug that in right there because it equals 92. So instead of yellow equals 90 and green equals 90, I can say yellow equals green, which is what happens right here. There's the yellow equals, there's the green, right? And so when you replace like that, that's called substitution. Okay, so down here we've got 3 equals 4. I think on your page it might be a little bit different. It might say, it might have left that one blank. But over here, if you notice 3 equals 4, measurement of 3 equals measurement of 4, that's the only given left. So this one's going to be given. Right. And in fact, I'm going to cross that off, even though it's correct. I'm just going to put it in a different place. So I'm going to write the measurement of 3 right here. I'm going to write the measurement of 4 over here. And I'm actually lining these up on purpose, right? So that the 4s are right below each other, the 3s are right next to each other there. Okay, here's what we're trying to prove. I'm going to use the M version, right? Because we're using M's all the way through this problem. So I know that I have to end with M angle 1 equals M angle 2. And so the question is, well, how do we get there? And if you look at the 2 steps before it, you've got 1 plus 3 equals 2 plus 4. And we could end up with what we want if somehow we could get rid of the 3 and the 4. Well, we can because the 3 on the left side is the same as the 4 on the right side. So if I just subtract straight down, I've got 1 plus 3 minus 3 is just the 1. And 2 plus 4 minus the 4 is just the 2. So this is subtraction right here. And then I'm going to add in a little extra line. We're basically doing line 3 minus line 4 equals our line 5. Now this isn't required for a test or anything, but if you put it in your notes and you come back and look at it later, it should make more sense what happened. If you don't put it there, you might be sitting there wondering, where's the subtraction happening? Okay, so that's how 1 works. That's how 1 works. So the new idea here is how to use this. Now, in class, some students were asking, why is this one definition of complementary angles and not the angle addition postulate? Well, if you look at it, 1 and 3 do add up to form the big angle right here. But we don't know what that big angle is. We only know that it has to be 90 because I was told they were complementary beforehand. So that one, you're using the fact that they're complementary to get the 90. Okay? All right, let's keep going. So all the way down to number 2 here. Okay. So in number 2, the idea is that you've got some given info. Okay, here's one piece of given info. Here's another piece of given info. Okay, so that means that if we were doing like some sort of proof, these would probably appear near the top, right? E is the midpoint of AB. That's given. And EH bisects angle BET. That's given. So then the question is, all right, as I go through these parts, they could essentially be the next step in some proof where these two things are the given info. And the question is, what are the reasons going to be that you put here? So what justifies each statement that I'm making in A through I? So let's kind of work our way through them. If I said AE plus EB equals AB for this step in the proof, well, most of you should just be able to look at that and say, oh, I'm adding two segments together. They're next to each other. I'm adding them together to get the big segment. Well, that's called segment addition postulate. And if we go back and look at the reasons that we had, segment addition postulate's up here. Notice it doesn't even matter what comes before it, right? All that matters is that the 3 points, A, B, C, are all lined up. And if we come back over here, A, E, and B, they're all lined up. So I'm allowed to just do this one. It doesn't even matter that I have this given info here. So the thing that justifies this is the segment addition postulate. Okay, so let me erase this one. Let's pretend that now we're looking at B. So the question is, what would justify putting this in my proof? HET plus measurement of TEA equals the measurement of HEA. So if we look at those angles, HET is right here, so that's this angle, plus TEA, which is this angle next to it. You add them together and you get HEA, which is the whole angle. Right? Well, if I take two angles next to each other, add them together to get the big angle, that's the same thing as the angle addition postulate. Take two angles next to each other, add them together to get the big angle, angle addition postulate. So this one, angle addition postulate, would be my reason that goes here. And notice, it doesn't actually depend on the given info in this case. And just like here, angle addition postulate doesn't matter what comes beforehand, right? You can always do it if you have two angles next to each other. So over here, I'm going to write, the reason that we're allowed to say this is because the angle addition postulate says we can say it. It justifies it. Okay, let me erase these. Okay, so the next one says E is the midpoint of AB. Why is that true? Well, a lot of times students end up getting stuck on this, but this is one of the more obvious ones. It's given, right? Given. So let's look at the next one. HET is half of BET. Measurement of angle HET is equal to half the measurement of angle BET. Why are we allowed to say that? Okay, Well, here's HET right here. And we're saying that it's half of this angle here, BET. Okay, well, we know that EH, this thing, cut the angle in half because it's a bisector. So it should make sense that this is half of the whole thing. So let's go back and look. What thing says if you have a bisector, then one angle is half of the whole angle? So if we come back over here, none of these things have to do with half of a whole angle. But if we come up a little bit, notice there's definition of angle bisector. You start with a bisector, but this says one part equals the other part, not a half. Whereas the theorem says one part equals half of the whole thing. So this is going to be the angle bisector theorem that we're using here. So let me come back over here. This would be angle bisector theorem. So, and it's because we have the bisector, and then we can say, okay, so one angle is half of the whole angle. Angle bisector theorem. Okay. In E, we've got EH bisects BET. EH bisects this angle. Well, okay, that's also a given. So don't overlook the given stuff. In F, we're saying, okay, what about AE is congruent to EB? By the way, the or here is just the equals version. The equals version is if you're talking about how long the segments are. The congruent version is if you're talking about the actual segments themselves, like the sticks, if you could pick them up and move them. Okay, so what allows you to say AE equals EB or is congruent to EB? Well, that means this one equals that one. And the thing that tells us we're allowed to do that is because E is the midpoint, right? We already know E is smack in the middle because that was given info. So there's one reason that we have in our list of reasons. It says if you have a midpoint, then one side equals the other side. So if we go back and we look at our reasons, it's not the midpoint theorem, because the midpoint theorem says one side is half of the whole thing, not one side equals the other side. So let's look up here. Here's the definition of midpoint. You have a midpoint, so one small part equals the other small part. Okay, that's what we just used here. We have a midpoint, so I said one small part equals the other small part. So this is going to be the definition of midpoint. Okay, in G, we're doing AEH plus measurement of HEB, right there, equals 180 degrees. So I'm taking two angles that are next to each other and adding them together to get the big angle. Okay, so if we come back to our reasons, we've got, let's see here. Nothing says equals 180 yet. Here's one. Two angles next to each other add up to 180 degrees. Right? So this plus this equals the whole angle. So angle addition postulate looks like it works, and it doesn't matter what came before it. But in class, some people notice that there's another one that says something similar, right here. Right? 1 plus 2 equals 180, but it has a reason that's different from the angle addition postulate. But notice with the supplementary angle, if you want to use a statement like this and give it a reason, if you want to use definition of supplementary angles, then this has to appear before it in the proof. You have to be told they're supplementary, and then you can say they add up to 180. But in our proof over here, we weren't told that the angles were supplementary in the given info. We're just told that they happen to add up to 180, right here. So then you got to look at the picture and say, oh yeah, they are next to each other, so they add up to the big angle. So that one is the same thing as the angle addition postulate, not the supplementary angle one. It turns out that yes, they are supplementary, but you didn't know that they add up to 180 because of that. You knew they added up to 180 because they're next to each other and form a straight angle. So that's the angle addition postulate. Okay, let me clear that off again. Okay, let's see. The next one, TEH, measurement of TEH equals the measurement of HEB. Measurement of TEH equals the measurement of HEB. So the question is, why are we allowed to say that? So remember, we have this. We've got that bisects this angle, right? So somewhere we've got a rule that says if you have a bisector, then one small part equals the other small part. And if we come back to our reasons, let's see, where's something that says one angle equals another angle? This one says one angle equals another angle if you have a bisector, but its one angle is half of the big angle, not one small part equals the other small part. So it's not the angle bisector theorem. Here, we have a bisector, so one angle is the same as the other angle. One little angle equals the other little angle. So that's definition of angle bisector. So that's going to go here. Definition. Whoop. Oh, somehow I started this. Okay, that's going to pop up in a second, I guess. But this is definition of angle bisector. And the or is, if you use the measurements, then you're talking about degrees and you use equals. If you're just referring to the angles themselves, then we'll use congruent instead. So no M in front for congruent. Okay, and then there's one more part here. BE is half of AB. So if that went here, BE equals half of AB. Well, let's take a look at the picture. BE is half of that segment AB. Well, we're allowed to say that. The one thing that we knew that lets us say that is E's right in the middle, right? And that's because of that given. So we started with E's the midpoint of AB, and then I said, so one part is half of the whole. Okay, if we come back to our reasons, one part is half of the whole. Well, this one says start with a midpoint, but one part equals the other part, not half of the whole. So if I scroll down a little bit, M is the midpoint, one part is half of the whole. That's because of the midpoint theorem. So back over here, midpoint theorem. Okay. These I think are a bit confusing for a lot of students early on, but the more we do it, I promise the easier it'll get. So, okay. So then there's one more follow-up question here, and there's a typo here. That should actually say number 2G. So suppose that 2G was something used in a formal two-column proof, like below. So we had all these various things that might have come before in the proof. And then at some point you end up with this line from 2G. AEH plus HEB, the sum of those measures is 180. And we already knew the reason was this. Angle addition postulate. So then the question is, what could follow? What could we say after that? Well, if I know two angles add up to 180, then I know that those angles are going to be supplementary, right? And if we come back to our reasons over here and look at that supplementary one, look, if you know two angles add up to 180, for whatever reason, then you can say that they have to be supplementary, because that's what supplementary angles are. So right here, I'm going to say, well, I know these two angles have to be supplementary. Angle AEH and angle HEB are supplementary angles. And the reason is because that's the definition of supplementary angles. Okay? So I hope that helps a little bit, and yeah, good luck with this stuff. If you're confused, do come find me for extra help, because you don't want to let this sit too long. It's okay to be a little confused early on with this stuff, because yeah, it's kind of weird since most of you have never seen anything like this before. But if this stuff really makes absolutely no sense to you, come talk to me soon, because you don't want to let this build up. Otherwise, the rest of the unit's just going to be awful. So, but I do promise, the more we do of them, the easier they should get. The more they should start to make sense to you. All right, I'll see you in class soon. Bye-bye.